What is this? Which one will get? So we saw this, right? We were generating the labels. So I had left here for the true list and the false list. What will be true list and the false list? Refer back the translation schemes.
Ma'am, true list is 100, 104.
100, 104, because it is the true list of.
To merge B1 true list, B2 true list.
Yes, very good. So it is 100, 104. So B1's true list and B2's true list we are merging for B's true list at here. For B, B1 or MB2. Now B dot false list, it will be
103, 104, 105. That is B2 false list.
So according to the translation scheme which we have for B1 or MB2, B dot false list is equal to B2's false list. B2 false list is again a merge of B1's false list here and B2's false list here. Okay, so that's why we are getting a list here. Right, this is how true list and the false list is getting created at each of the node. Now backpatching we have not applied yet, because we have to backpatch this m.I to either true list or the false list. That function is remaining. Okay, so at B and MB2, B1 and MB2, for B, what are we backpatching onto? So when it is reducing, this particular B and B is getting reduced to B, that backpatch function is also called, right? We have considered only true list and false list yet. So we are supposed to call that backpatch also. Backpatch is on what? For B1 and MB2. Backpatch is on
True list.
true list. So at 102, I have to backpatch this index. Okay, I have to backpatch this index. That is nothing but target of the jump. So at 102, I have a true case. Okay, what will I do? I will backpatch with m.I. So that is 104. Right now, here when you come, B is B or MB2. Here also we have a backpatch on what? Backpatch on this 102. I have to backpatch with something. When this is getting
false
reduced.
list address.
False list of
B2, B1 false list.
B1. So 101, I have the false list, right? So I have to backpatch this index with the false list. Okay, that is how the backpatch is working. Now, backpatching is also getting called, right, with the reductions. We had only seen the true list and false list creation. Now, this is how the target of the jump is getting backpatched. Okay, so when you have, see here, x less than 100, then go to, this is S next, right? So that's why the target of the jump will be, given by the control statements. If B, MS1, those statements it will be given, because only we are giving here what when it has to go to the next B. Okay, so on the false, if x is less than 100 is false, then I have to check the this whole statement, right? If B1 is false, so where it has to jump? It has to jump to the code for this particular even relational operator E2, right? So 102 is the index of that, right? So on the false list, we are jumping onto 102. Now, once we do this, then we have certain case. If x greater than 200, so at 102, I have x greater than 200 since it is AND. Okay, if this is true, then I have to go to 104, right? So 102, that's why for the true list, we have backpatched 104. 104 is the index of true list. Okay, this is how backpatching works, right? We will also see the translation schemes of if, while, if else. Okay, this you understood, this example? The leftovers should be filled in the control flows for if else and stuff like that. Okay, because it is surrounded by if, right? In the other cases, it should jump over this to go to this, x is equal to 0. If you see, if x less than 100, I have to go to this particular statement, right? If this turns out to be false, it should go to s dot next. If this turns out to be true, what it should go? It should go to x is equal to 0. If it is false, it should go to s dot next. Those labels are filled by if control statement translation schemes. This cannot backpatch it. Only the execution of Boolean expressions inside this, I can backpatch with the address location of the 3 address code for those relational operations. Okay, any doubts here? All right. Then we'll
Ma'am,
see. Yes.
ma'am, so all the other things cannot be backpatched?
No, not in the Boolean expression, right? So you have a
Okay.
pass for this, and you have a pass for this if statement. We will be using if b s1. So there also I'm creating a couple of labels, right? So it has to be backpatched there.
Okay, ma'am.
Okay. So have this in your notes, okay? Because translation schemes for control statements we are going to see next. So all these doubts of yours when this will get patched, so that will be clarified when you go through the if control statement. Okay, because there you would have generated s dot next and stuff like that. Okay, true and true list and false list, there also you're generating. Because I have to say whether this is true or based on that I have to jump to x is equal to 0. If this is false, I have to jump to s dot next. All those things are there. So there also we generate a couple of labels and backpatch them. Okay. Now you just refer back to the flow of control statements which we have used before without backpatching. Just have a look on that. So we had used this. We now have to modify the that S gives grammar. You had no S gives if B S1, S gives if B S1 S S2. So now we need to have that index being induced, okay, to the given grammar. So it is first one is S gives. Now we started with L gives S. Okay, L gives S they have given at the end, and L can give LS. So L is a set of statements and it can be a statement and a statement. Okay, it's like that. So those things they have discussed later, but it's a complete grammar. Should be okay. Started with if B, we introduce M, S1 because M should have the index of S1 score. Now you're familiar, right? Now what could be the, refer the same functions. Okay, so backpatch on what? I need backpatch or not? Do I need to have backpatch or no? Only 28 people buy? Is there anything going on? Some placement activity or something?
I think more than half of them have internships, man.
Yeah, it's there, but it's a serious problem. How do you balance the attendance then? This is really low. It's a 80 student class and we have 29 people. I don't know. Okay. Backpatch on what? Do we have to have backpatch or no? So here also we have the labels. See, B true list and B's false list is already manipulated. So we have to see what should be there at S1's next or SS next, like that. Okay, we have to generate those things because B's is already done. So refer back to the SS if B S1. So B dot true and B dot false is already done. So we have to see what will happen with the SS labels. Okay, so backpatch should be there on whenever B is true, right? So B dot true list, I need to backpatch with the M dot instruction because M will have the address of S1. So whenever B is true, I have to jump to this target, right? Which this index, M's index, which is attached to S1's code. Okay, so you had left if X less than 100, go to that B true. That label was left out, right? So this will backpatch that. Okay. Now, what is S dot next list? Here, instead of next, we will have X dot next list. It is all lists here that I've told you. So what will be S's next list? It will be, what will be there after S? It will be a merge of, if B is false, it has to go to S is next and S1 also should go to S is next, right? So S dot next will be a merge of B dot false list and S1's next list. Getting this point? Okay, so S dot next list is nothing but a merge of, if B is false, then I have to jump this, right? I have to go to S is next. If after executing S1 also I have to go to S is next. Okay, understood? Now, for if else statement, if B, then M1, S1, I need to have one more nominal here to hold the index. I will tell you why. M2, S2. So we have M1, N, M2 being inserted here. What is the use of N here? Anyone can guess why do we need N here or not?
Ma'am, N will be the jump statement after executing the true.
Yes. So we have several jumps here. If B is true, then I have to backpatch this M1 to the true list of this, right? Then I need to have how many backpatches here? 1 or 2?
2, I guess.
2. So because for true list, I have to backpatch M1. For false list, I have to backpatch
M2.
M2. Yes, exactly. Because I need to go to S2 skipping this. I have to skip this, right? So backpatch will be called twice here. Okay, with true list and false list. So backpatch B dot true list is on M1 instruction. Okay, then backpatch B dot false list. So M2 will have the index for me. So I will backpatch with this. So whenever B is false, it has to jump to M2's index address. Okay. Now, to give S dot next list, what are all I have? S dot next list will be a merge of what? Where and all I will jump to S dot next. Here it was straightforward. After S1's next and whenever B is false. Now here, it should be S2's next, right? Then whenever B is false, it will go and execute S2. So it is S2's next, S1's next, right? Then
B false list.
B false list will jump to S2. So S1's next is given by N. Okay, to have this jump. So X dot next can be a merge on inside a merge. So you can have a temporary list being created, depends on how do you implement it, or you can call inside a merge another merge. Okay, so it will be the merge of S1's next list and N dot next list, because I have already introduced N here, which will have the index of S's next. Okay, so it will be a merge of S1 dot. It will be a merge of S1 dot next list, comma N dot next list.
Ma'am, isn't N S1 dot next only? Then why do we have like?
No. So S1's next list is created
When B is true.
so we have to use another marker. This N and M are called as marker non-terminals to generate the jumps after S1. N is a separate marker for it. Okay. So that's why, because when I say S, it has already created those labels for me. So S1's next also I have to consider for merging. So it will be S2's next list. And this will be again a merge of S1 next list and N's next list.
Yes, ma'am.
That is about when you have S, if B, M1, S1, N, because N is next, S1 is next, and S2 is next. 3 will be there for S dot next list. Okay, that's why we have this merge inside merge. Or what you can do is you can create a temporary list of one merge, which is this one. You can put this merge over here and put this temp here. Okay, so it's a call inside call. You can do that also. Now we try for while. I will write the while B. I need to have no, before B I need to have a marker, right? Because I need to have a label jump there. So whenever I need to have a jump, I need to have a marker. So B and M2 S1. Okay, because after S1 I may have to jump back to M1, right? So here how many back patches we require? One or two or how many? See, on B's true list, what I have to do? I have to backpatch M2, right? Now, once I execute S1, because M2 will be the address of S1, so I will execute S1. After S1, what should I do?
Backpatch to M1.
Yes. Okay. So S1 next list will be backpatch to M1. Okay. It cannot jump over S. Since till B becomes false. So your S dot next list will be B dot false list. So you don't merge or you don't do anything else, because B is false means it should go to S is next, right? So you have backpatch on B's true list with M2's instruction, right? Then you have backpatch on S1's next list with M1's instruction. Because after executing S1, I have to jump to this index, wherein I have B's code. Okay, then what is S dot next list? It will be it is straight away depending on B's false list, right? Okay. Then with this, we have to emit this also, because it is unconditional jump, right? It's a loop. So I have to generate go to. Go to with what? After S1, it will go to with what is an index or the label which I have to jump to? M1 dot instruction. I have to emit this particular statement. So it will give go to this index. Okay, whenever you are executing the loop, you will have a unconditional go to statement to show that loop. Okay. Now, the fourth one is if it is there in a block, it is straight away S dot next list is L dot next list. I think you can go through that. So whenever you have introduced M and N, right? So M gives epsilon, it will be M dot instruction is equal to next instruction. Okay, but when you have N, so N dot instruction or the list it is not an instruction. So here M is an index, but N is a list. So you have to create that list. N dot next list will be, you have to call make list, next instruction. So the difference between M and the N marker is M will hold the index, right? But the N will have the next list. Okay, it is a list. It's not an instruction. So that's why we have to create the list here, and we have to say emit also, because after this you have to say go to this code, right? So emit go to dash. This code dash should be patched whenever you have S gives F, this one, right? So backpatch should fill this up. And another 2, and this is set of statements. That is straightforward. So L can be L1 M S and L can be S. So here in this case, what you do, you have to backpatch what? L1 dot next list with the M instruction. Because after executing L1, you have to jump to M. And L dot next list will be S's next list. And for this, L dot next list will be S's next list. This is straightforward. Okay. Example, I want you to see whatever the dashes we have left in the previous example. No, refer this. It's a kind of if statement, right? So you have to refer to F gives if of B M S1 and try to complete that blank spaces and let me know in the next class. It's a homework for you. Okay, whether you are able to complete that or not. You can backpatch with the if you don't know the instruction number, you can say true or false or something like that. Okay, so do that exercise. Okay, so this completes the backpatching topic. Main thing here is how do you write the translation schemes for the production, both for the flow of control statements and for the Boolean expressions. Usually they'll give you the grammar and I'll ask you write the backpatching translation scheme for this. They won't usually give the whole grammar. Maybe only S gives if B S1 M1 S1 and else M2 S2 like that. Write the backpatching code for this particular production. They can give you like this for 2 marks, 3 marks like that. And also for the Boolean expressions. Okay, usually they won't give you the whole grammar. If at all, if they give you, it will be for more than more than 5 marks, 8 marks or something. But you have different concepts being introduced here, so it may be asked in the quiz or something like that. Okay, you have to do that homework. Now, now everybody joined. Very good. We'll start with the third unit. Lex and York, anyways, the demo is done. Error recovery you have to do. Before that, we can start with the.
Excuse me, ma'am. Ma'am, in the backpatching one, can we do one problem on the for loop? Like, is it possible?
For loop.
S gives. Yes, I just wanted to know how to solve that question.
For loop we haven't discussed only. No, it will be either if else, if or while.
Okay, so that's out of syllabus.
Yes. For loop, because for each of those looping statements, right? Looping statements or break statements, continue statements, it's a different address code generation method. So you should have L gives for. Okay, and
Yes,
it has.
so inside there will be this thing, right? There will be one initialization and one condition.
So all together, it's a different methodology, right? So it has not been discussed. It is not there for your syllabus. For switch also, it is a different thing. Switch also, it is entirely a different topic, how to generate the 3 address code for switch. So specific.
They're based on condition, I guess we have to backpatch in switch. Like there will be several M's, like M1, M2, M3 till M1. And based on the argument we pass in the switch, we have to make different lists of that, and based on that attach the respective M instruction.
For switch, you have normal, before we had discussed both Boolean and flow of control statements, right? There you have 3 address code generation for switch also, not for backpatching. Without backpatching, you have it in the book, but you don't have it in the syllabus. If you are interested, you can go through that, how to generate the code for the switch without backpatching. It's there in the book, prescribed book. Okay.
Yes.
You try that if statement, which I have solved for Boolean expressions. You have to take this and see how those empty spaces are there. No, we have just backpatched 102 and 104. So how further the jumps will be backpatched into that code. You have to do that.